Hey guys, this is Regents Spiral number 5. We're in June 2024. That's the white Regents. Question 1. A ball was launched into the air and its height above the ground was recorded each second as shown in the table below. Based on these data, which statement is a valid conclusion? The ball lands on the ground at 4 seconds. So the ball would have to land on the ground when this y or height is 0, and it doesn't have a 0 on the table here, so we're gonna cross that guy off. The ball reaches a maximum height of 11 feet. Well, that's not true. This is the maximum because there's symmetry on either side of that lone 75, and the maximum value or maximum height is going to be 75, so that's not true. And then 3, the ball was launched from an angle, launched from a height of 0 feet. Well, that is not true because when time was 0, the initial starting height was 11 feet. The ball reaches its maximum height at 2 seconds. That is totally true because we found that this is the vertex or the maximum and the time is 2. The ball reaches its maximum height at 2 seconds. That's correct. Question 2. A tour bus can seat at most 48 passengers. An adult ticket, that's going to be one of my totals there. An adult ticket costs $18 and a child ticket costs $12. The bus company must collect at least $650 to make a profit. If A represents the number of adult tickets sold and C represents the number of child tickets sold, which system of inequalities models this situation if they make a profit? So a system of inequalities means I'm going to be writing more than one. I have my two totals right here, at most 48 and then at least 650. So let's find the inequality symbol for at most 48. At most, I'm going to put 48 in the middle, put 1 below and 1 above. At most, can it be 48? Sure, it can be 48. But that has to be the most, so I must shade down. This guy must be less than or equal to 48. Let's do 650. 650 is at least 650, so let's do the number line for 650. I'm going to put 650 in the middle, 1 below, and 1 above. At least 650. Can it be 650? It can be 650, but it's got to be 650 or more. So this whole representation to the left must be greater than or equal to 650. Okay, now 650 is the one that's talking about money and 48 is the one that's talking about quantity. So let's go ahead and put the quantities together, okay? The total number of tickets sold must be at most 48. So A plus C must be less than or equal to 48. Whereas the cost of each ticket is going to be $18 per adult ticket and $12 per child ticket, and that must be greater than or equal to the total profit of $650. So we're going to match these with the answer choices, and it is choice 2. Which equation is always true? Always true means use your laws of exponents to see which one is right. When I multiply like bases, I add the exponents. This one is correct, therefore it's always true. Why is this one not correct? Well, I have a like base of 3. If I added those exponents, this guy should be 3 to the x plus 2. This guy here is not the same. If this was in parentheses, it would be the same, but they're not the same, and it's not in parentheses. And then here, we have a like base of 7. When I multiply like bases, I add the exponents. This guy would be this, not that. Answer is 1. Question 4. The expression -2 times x squared minus 2x plus 1 plus 3x squared plus 3x minus 5 is equivalent to. The good news about the word equivalent means that you can test your answer in the calculator, okay? So let's go ahead and do it algebraically, and then we'll go over how to do it in the calculator if you get stuck with the algebra. So first, I'm going to get rid of my parentheses by distributing a -2 to each term. -2 times -2x gives me positive 4x. -2 times positive 1 gives me -2. Now I'm adding this whole second trinomial here as well. Now I'm going to combine like terms. I have an x squared over here and an x squared over here. I have an x here and an x here, and then I have a constant here and a constant here. So all together, let's do the x squareds first. Negative 2x squared plus 3x squared gives me x squared. 4x plus 3x gives me 7x. Negative 2 minus 5 gives me negative 7. The answer is choice 4. Now let's say you wanted to check your answer and make sure that you were right, or you didn't know how to get started. Here's what you can do. So equivalent means that I can use my calculator to figure out the answer. The way that you could do this for equivalence is, since this is an expression, I can meaning it has no equal sign, I can store a value for x. Let's store a 2. Now I'm going to type in the original and see what that value is when the x value is 2. Okay, so let's go ahead and see what that would equal. Okay, so when x is 2, this whole piece up top should be equal to 11. So let's test the answer choices, right? And I'll show you what we mean by trying to match an 11 up here, okay? So for answer choice 1, if I typed that in as is it going to be equal to 11? It is not equal to 11. Answer choice 2, let's type it in. He is not equal to 11. Answer choice 3, let's type it in. He is not equal to 11. Answer choice 4, let's type it in. He is equal to 11. Yay. So you can not only use this to get you started if you don't know what to do, you can also use it to check your answer, and we know now that our answer is correct. Question 5, which sum is irrational? An irrational number is a number that cannot be written as the ratio of 2 integers, and that is your formal definition for an irrational number. If they ever ask you why a number is irrational and it's like a part 2 or a part 3, you would explain by saying it is a number that cannot be written as the ratio of 2 integers. Then you can go further to explain how did you know. You would know by knowing that an irrational number is a decimal that follows 2 criteria. It goes on forever and never repeats a fundamental pattern. Okay, so it needs to go on forever and never repeat, and it cannot be written as the ratio of 2 integers. That is the quintessential definition of an irrational number, okay? So let's go through and test all the answer choices and see which ones end up being a decimal that goes on forever and does not repeat. Negative 2 times the square root of 12, 12 plus 100. Oh, the square root of 100, sorry. Oh my goodness. Okay, that ends at 972. I pick up the decimal and see if more digits come up past it, and they do. So I'm going to go ahead and select answer choice 1. He's irrational. The solution to 4 times x minus 5 over 3 plus 2 equals 14 is, oh great, okay, so what I want to do here is I'm going to use nsolve to get the answer, then I'm going to match my answer to what nsolve was if I wanted to do it algebraically, okay? Since this is multiple choice, I can just type it into nsolve and get the answer though. So I have menu 3, 1. I type it in the way I see it. Start with the fraction, so that way you can put everything up in the numerator, then go down to the denominator. Otherwise it gets a little funky. Get out of the fraction, add the 2, equals 14. You must put comma x at the end or it won't know what to solve for. The answer is 14. How could you do that algebraically if you wanted? You would have 4 times x minus 5 over 3 plus 2 equals 14. I'm going to minus 2 minus 2. I'm going to have 4 times x minus 5 over 3 equals 12. I'm going to multiply both sides by 3 to get rid of the fraction. I now have 4 times x minus 5 equals 36. I'm going to divide both sides by 36. And I now have x minus 5 equals 9. I'm going to add 5 on both sides. X equals 14. That's exactly what I got with NSolve. Cool. 7. On an island, a rare breed of rabbit doubled its population. You're going to underline doubled its population. Anytime we double a population, that's multiplication. That means this guy's going to be exponential. Each month for 2 years. What type of function best models the increase in population at the end of 2 years? Okay, so we know it's exponential because the amount or the population is getting doubled or times 2 every year. And then the type of function that best models the increase in the population is going to be growth because the population is going up. Remember, going up, growth. They both start with the G. The population is going up every year, so this is growth. We now have exponential growth. Answer choice 3. Question 8. What is the degree of the polynomial 2x minus x squared plus 4x cubed? You are looking for the highest exponent present. The highest exponent present is x to the third. Therefore, the degree is equal to 3. Answer choice 3. Question 9. The zeros of the function f of x equals x times x minus 5 times 3x plus 6 are. So zeros are the x equals. So what you're going to do for finding the zeros from the factored form is rewrite it, but rewrite it set equal to 0. Now we just split and solve. There are 3 factors. I'll have 3 parts on my chart. I set the first factor equal to 0. I set the second factor equal to 0. I set the third factor equal to 0. Now I solve and I get my zeros. X equals 0 is already done for me. I do x minus 5. I add 5. I have x equals 5. And then now here I'm going to subtract 6. And these are my zeros. So I now have 0, 5, negative 2. 0, 5, negative 2. That's answer choice 2. I can check that on my calculator by graphing that original function and looking for the x-intercepts. Remember, that's another word for the zeros. So I'm typing in x minus 5 to a graph page. And then I am graphing it. And I see I have zeros at negative 2, 0, and 5. There we go. Okay. What is the y-intercept of the line that passes through the points negative 1, 5 and 2, negative 1? Okay, this is a difficult question. What I'm going to want to do here is I'm going to get the slope between the 2 points. I'm going to put that slope into point-slope form, and then I'm going to pick one of the points for the rest of the equation. Then I'm going to graph that line and see what the y-intercept is. There's kind of a lot of steps, but that's okay. I got this. So I'm going to find the slope between the 2 points first so I can use it in my equation. Negative 1, 5, 2, negative 1. The slope between these 2 points is going to be, how do I get from 5 to negative 1? I subtract off 6. How do I get from negative 1 to 2? I add 3. Change in y over the change in x is going to give me negative 2. So I now have a slope of negative 2. And I'm going to use point-slope form of a line. Let's go back to our reference sheet because point-slope form of a line is always on our reference sheet. And I'm going to copy this down right here. Linear equation, point-slope form. Y minus y1 is equal to m times x minus x1. Great, I got it. Back to business, where are we? Okay. So I'm going to start with point-slope form of an equation. Y minus y1 is equal to m times x minus x1. I've selected this point to go in. It doesn't matter which one you pick. This is my x1. This is my y1. I now have y minus negative 1 equals negative 2 times x minus 2. I'm going to graph this line right here in my calculator. I'm going to graph it in relation mode because y is not by itself. Y minus negative 1 turns into y plus 1. So I'm just going to do that. And then equals negative 2 times x minus 2. Okay, now let's find the y-intercept. And it is 0, 3. So the y-intercept is 3. 11. Nancy has just been hired for her first job. Her company gives her 4 choices for how she can collect her annual salary over the first 8 years of employment. Each function below represents the 4 choices she has for her annual salary in thousands of dollars, where T represents the number of years after she is hired. Which pay plan should Nancy choose in order to have the highest salary in her 8th year? So what I should do here is substitute in 8 for every different equation here. And then I'm going to compare the outputs and see which one is the highest, okay? So in the first one, I have a of 8. That's going to look like 2 to the 8th plus 25. I'm going to type that into my calculator. Remember, when you're typing in evaluation problems, you don't type in the left side, you only type in the right. I have 2 to the 8th plus 25. Oops, sorry, oh my goodness, what am I doing? 25, there we go. And I have $281, okay. So A of 8 is $281, so this guy's gonna be $281. Let's type in B of 8. That's gonna look like 10 times 8 plus 75. I'm only typing in the right-hand side, okay? And not the equal sign, sorry, there we go. There we go. 10 times 8 plus 75, 155. I'm going to do the next one, square root of 400 times 8 plus 80. So this is all under the square root. I have 400 times 8, come out of the square root, plus 80. It's 136.6-ish, I guess. And then D of T, oh, this is a big one. Okay, I got 2 times 8 plus 1 squared minus 10 times 8 plus 50. All right, I'm only typing in this part to get the answer. And it's 132. So the highest number is going to be 1. Answer choice 1. Question 12, the third term in a sequence is 25. Okay, so third term in a sequence is 25. A sub 3 is 25. Okay, that's my first clue. And the fifth term is 625. A sub 5 is 625. Which number could be the common ratio of the sequence? The common ratio is going to be the multiplier in a geometric sequence. And the way that you find an unknown r is, let's say you had the third term, right? I'm going to make my little chart because this helps me when I have unknown terms. I have the third term. Oh, sorry. I have the third term. And then I have the fifth term. And then these are all unknown. Yeah, I don't know what those are. So what I'm going to want to do here, right, is, in order to get from this term to this term, I must multiply by some unknown r. In order to get from this term to my other clue, I have to multiply by some unknown r. How many r's did I have to multiply by? 2. So you had to do r times r to get to 625 when you start at 25. So what I'm going to do is do 25, r times r becomes r squared. And now I can just use inverse operations to solve. I'm going to divide both sides by 25. And then I have r squared equals 25. I now square root both sides to undo the exponent. I have r equals 5. Square root of 25 is 5. My answer is 5. Now, if you didn't really know how to do this, or you didn't know how to start, you could always just take the 25, right? And you're currently at the third term, and you could just like test the answer choices, right? So if you're currently at the third term, you have to multiply this by 1/5 one time to get to the fourth term, and then another time to get to the fifth term. And does that give you 625? No, it doesn't. In fact, everywhere we see a fraction, we can eliminate that because that means the numbers are going down. And to get from 25 to 625, the numbers are going up. So we would test 5 and we would see, okay, I'm starting at 25. I multiply by 5 to get to the fourth term. I multiply by 5 to get to the fifth term. Okay, the answer is choice 2. Question 13. The box plot below summarizes the data for the amount of snowfall in inches during the winter of 2021 for 12 locations in western New York. What is the interquartile range? The interquartile range is on your formula sheet. So go ahead and scroll, or turn, I guess you have a physical copy. Turn to the back page and look at your formula sheet. And I am now looking at the interquartile range. And that can be found by doing Q3 minus Q1. So I'm going to go up. And I have to find the IQR, which is Q3 minus Q1. Let's find Q3 and Q1 on the box plot. So visually, Q1 is going to be the start of the rectangle, and Q3 is going to be the end of the rectangle. Q1 is 60. Q3 is, let's see, what are we counting by? 1 to 120, and then there's a tick mark in the middle, so that's going to be 110. So IQR is 110 minus 60. 50. Answer choice 2. All right, let's go to 14. We're crushing it. Here we go. 4 quadratic functions are represented below. Which function has the smallest minimum value? Let's go through each problem and figure out the minimum, right? So this is a quadratic. I'm going to graph him and see what his minimum is. Remember, minimum value is just asking you to compare the y's. So that doesn't look like a y. The y's. So let's graph the first one. It is going to be x minus 3 squared minus 7. I'm going to find the coordinates of the vertex, and they are 3, negative 7. Since I'm comparing minimum values, I only care about the y. Okay, 2 is going to be another quadratic. I'm adding a new graph because I don't want to get confused. Again, find the coordinates of the vertex. They are negative 3, negative 6. Remember, I'm comparing minimum values, so I only care about the y's. This guy's on the graph. This is easy. That's good. It's 1, negative 1, negative 2, negative 3, negative 4. So it's 1, negative 4. Again, I'm comparing minimum values, so I only care about the y's. And then on a table, I make the matches until I'm left with the lone wolf, and he is my vertex. The minimum value of this guy is negative 5. So what's the smallest minimum value? That's going to be this guy, negative 7. Answer choice 1. Oh, that's it for 14. Okay, great. Let's scroll over to the part 2 questions. These are worth 2 points each. So when you're taking this test, try to think like a person who made the test, right? What do you think the 2 points could be worth? If there's any mention of rounding, you're going to need to make sure that you've rounded correctly, or you lose a whole point. If it's a graph question, you're going to make sure that you put arrows on your graphs and you put labels on your graphs, or you're going to lose a whole point, right? So you got to think like the test maker sometimes. Okay, question 25. It says solve 5 times x minus 2 is less than or equal to 3x plus 20 algebraically. Do you see how the first question on part 2 is usually solving either an inequality or an equation? Good to know. Let's go ahead and distribute the 5 to get rid of the parentheses. We're going to fully combine on each side. If there's any like terms, there are not. Now we can begin to sort. Let's sort the variables on the left. And the constants on the right. The answer is x is less than or equal to 15. 26. It says, given g of x equals x cubed plus 2x squared minus x, evaluate g of negative 3. This is function notation. Remember, if we have something that looks like this, you could also have f of x equals y. Function notation just means that this is the x and this is the y, and it is the equivalent way of representing a coordinate on the function. It's the same thing as writing it like this. It's just written in a fancier way. Okay, so with that being said, let's take a look and see which number or which letter is negative 3 going in for. Everywhere we see an x, we are going to put in a negative 3. So I now have g of negative 3, and that's going to look like this. Remove the x, put in a negative 3. Remove the x, put in a negative 3. Remove the x, put in a negative 3. You're going to evaluate this on your calculator, but remember, we only type in the part on the right. So let's go to a calculator page, and we're going to type in negative 3 to the third plus, don't forget to put your parentheses around your negative 3 here. It's going to mess up your signs. Minus negative 3. And that's going to be negative 6. Okay. Since it says evaluate, you have to do it algebraically. It's like the same thing as seeing algebraically. So while you could check your work by putting this in a graph and finding and going in the table and looking where x is negative 3, since it says evaluate, you have to show the algebra. That means you have to show the substitution. Okay? 27. Given the relation r equals negative 1, 1, 0, 3, negative 2, negative 4, and x5, state a value for x that will make this relation a function. So we know that a relation is a function when x does not repeat. For every x, there is only one y. Since I've already used negative 1, 0, and negative 2, your x could be anything besides those 3 numbers. So let's make it, I don't know, 6. Explain why your answer makes this a function. In a function, for every x, there is only one y. No x's repeat. Therefore, when x equals 6, there is only one y. Okay. 28. A survey of 150 students was taken. It was determined that 2/3 of the students play video games. 2/3 of the students, what students? The 150 students. So 2/3 of, remember the operation of is multiplication, 2/3 of the 150 students play video games. So let's find out how many kids play video games. 100 kids play video games. Okay. So if 100 kids play video games, let's go to video games, let's go to total, and let's put 100 right there. Okay. Of the students that play video games, so we're in this column now, right? 85 also use social media. That means to find the kids who don't use social media but play video games, I would have to do 100 minus 85 and get 15. I know that there are 150 students in total, and I've already used 100 to play video games, so that means this must be 50. All right, I'm getting there. Then it says, of the students that do not play video games, so now we are in the do not play video games category, 20% do not use social media. So of the students that do not play video games, that's that 50 right there, 20%, so that's going to be 0.20. You got to turn it into a decimal for it to be a multiplier. You're going to find that as 10 kids. So that's do not use social media. That's 10 right there. So if there's 50 in this column, this has to be a 40. And now we can just add these rows together to get the totals. So 85 plus 40 is going to give me 125. 15 plus 10 is going to give me 25. Does this total up to 150? It does. Does this total up to 150? It does. We're done. Okay, let's go to 31 and 32. 31 is graph the following system of equations on the axes below, then state the coordinates of all solutions. Okay, so I'm going to type this into my calculator. Since I have two graphs, I'm going to type the first one in. Then I'm going to type the second one in. And then I'm going to find the points where they cross. Menu, 6, 4. Lower bound means go a little below. Upper bound means go a little above. And then I have my 2 points. Okay, so now I have like a bunch of information here, which is perfect, okay? Let's start with the line and get the points for there. Menu 5, 3, tell it what to count by. They started me on the blue graph. I would rather do the line first, so I'm going to go hit up and then get on the line. Okay, there we go. So I'm going to start. -5, -6. All right, the graph goes way further than that, so I'm going to get a few little points to the left a little bit. Okay, I'm going to see where this guy crosses. -1, 1, 0, 4, 3, 9, 8. Okay, and then I'll get one a little to the left, 13, 12. Okay, now I'm going to connect the line. I hope yours is straighter than mine. Oh, it did it for me. Wait, no, go back. There we go. Go back, go back, go back, go back. Ugh. Hold on, let's try this again. Okay, that's pretty good. Okay. Let's label this guy. He is y equals x minus 1. And then let's get the coordinates for the blue graph. So you hit up to switch from one graph to the other. I need to go way back down to get on here. Okay, 6, 12. Okay. This vertex is a little funky, so it's about 1.5 over, so it's halfway between these two boxes, and then I go down negative 8.25, so like right about there. So on the Regents, they would take points off if you didn't put the vertex there because you're not being precise. So you would have to kind of eyeball it, and that's a little difficult. Okay. Label this. And then let's make those intersection points really obvious. And let's write them. And then what's the other one? I can't really read that. Okay, -1, -2. Okay, so now it says state the coordinates of all solutions. Coordinates means the x and the y's. So you would just write them right here. You could put a comma or an and, whatever you want. That's that on 31. 32. The table below shows the amount of money a popular movie earned in millions of dollars during the first 6 weeks in theaters. Write the linear regression equation for this data set, rounding all values to the nearest hundredth. Linear regression equation means I'm writing the equation of the line of best fit. I'm going to get these inputs from menu 6, 1, 3 in the calculator, linear regression. Once I get those inputs for the M and the B, I'm going to round my answer to the nearest hundredth. Okay, here we go. I'm going to add a new document because I don't want old lists and spreadsheets fudging up my numbers, right? Okay, so I've got an X and I've got a Y. Let's see if they labeled who's X and who's Y. Okay, weeks are X, so I'm going to put those in my X column. And then our Y's are over here. Okay. Now let's add our calculator, okay? And then in here we do menu 6, 1, 3. X list is your X, Y list is your Y, and you hit OK. My M is negative 37.57 when I round it to the nearest hundredth. So my slope is negative 37.57, and there's an X next to it. My B is 215.6666. This number here is gonna round to, I look at this digit and I round him up. Or I guess I'm looking at this digit here. Ooh, hey. What's going on? Okay. I look at this digit here, right? And I'm gonna look at the digit to the right, and because it's greater than 5, I'm gonna round up, so this becomes 0.67, okay? Okay, that's my linear regression equation rounded to the nearest hundredth. And then it says state the correlation coefficient. Correlation coefficient is plain old R. Look on here for R, it's negative 0.98 rounded to the nearest hundredth. State what this correlation coefficient indicates about the linear fit of the data. You just have to say strong since it's close to 1 and negative.